Yeah. Hello everyone. Thanks for everyone in joining us today for today's webinar. We have a really great showing that Abe and I were really excited about. It's filled with a lot of factory owners and operators and executives. So on behalf of MicroAI, thank you once again for your attendance. So my name is Chu Nguyen and I manage digital marketing operations here. If you haven't heard of us here at MicroAI, we specialize in developing artificial intelligence and unsupervised machine learning to better understand and optimize machine intelligence, especially in an industrial 4.0 context. So lastly, I'm also going to be the host for this webinar, so you can find me engaging with any and all questions in the questions tab of the GoToWebinar panel. So if you also stick it out to the end of the webinar, I'm going to be attaching a lot of really cool thought leadership collaterals in the form of white papers in the handouts section. So I am here today with my colleague, Abe Kais, our industrial solutions engineer. I'm going to have him introduce himself, go into a little bit about his awesome background, and we'll kick it off shortly. So take it away, Abe.
Hey, how's everybody going? I hope we're all having a wonderful day, very productive and getting a lot of work done. My name is Abe Kais. I am the industrial solutions engineer for MicroAI. I have experience in industrial equipment management as well as maintenance, as well as years of experience of being a F-22 jet engine mechanic. So not only can I work on getting some of the insights out of this equipment, but I've been known to get my hands dirty wrenching on them in the past as well. So without further ado, I'd like to go ahead and get started on our OEE optimization and AI-enabled digital factory webinar. All right, so today we're going to be discussing the following points. So we will be discussing machine observability, maintenance practices, and the OEE barrier. Now, these are problems that we have noticed throughout the manufacturing and production facilities that we've been involved with over the years, and a lot of the issues that are being faced currently with facilities all over the world. Then we'll be getting into the AI-enabled digital factory, the impacts of AI and how that's going to help to solve those problems that are faced in the manufacturing process. We'll discuss MicroAI's Industry 4.0 architecture, as well as how we at MicroAI deployed the digital factory. And then lastly, we'll be discussing our smart factory in a box, and then end it off with a Q&A session. And so without further ado, let's go ahead and jump into the machine observability part. Okay. So a lack of observability is a huge part of a lot of the issues that are plaguing manufacturers to date. So what is a lack of observability? Limited visibility into the internal operations of machines, not being able to detect in real time when subpar performance or malfunctions are happening across the line. And this can lead to a lot of problems, such as lack of agility when it comes to meeting the challenges or changes that need to be made, whether it be in the production environment or due to market factors that are causing maybe some shifts in how much we're producing or what we are producing. All of these things are negatively impacted by having a limited visibility of what's going on in the machine. Another area that we've noticed a lot of people are having problems with is suboptimal load balancing. So when I say that, I'm meaning a reduced productivity based on, let's say, a starved block condition where you're having a lot of high cycle time issues, or maybe you don't have your buffers placed in the right area, or you have an operator not working at the right station. A lot of times these things compound over time and really overburden the asset and end up producing a lower quality product over time. And it can lead to more machine maintenance and breakdowns. And that's something we'll be getting into a little bit more here soon. Another area is the lack of comparative analysis. So not being able to compare the production of one machine or the observability from one machine to another machine and seeing what those differences are, those can lead to variance in performances of the machine or from machine to machine and shift over shift. So not being able to really have a concrete look at why did this shift do better than the previous shift or vice versa. And then finally, with the machine observability, the need for more predictive insights. So in today's day and age, we have a need for prediction, not just preventative. So predictive performance analytics is something that a lot of folks are really missing from their machine observability throughout manufacturing facilities all over the world. All right, so next we'll be getting into maintenance practices. This is another area that I have a personal tie to. Not only that, but it is one where a lot of folks have a lot of problems. So the legacy approach to maintenance is the preventive maintenance, right? We have our maintenance team going and visiting the assets, and we have a schedule for when this asset or this machine is supposed to have consumables inspected or be inspected throughout. And what that can lead to is, or what that is what we call a static maintenance routine. Dependency on these static maintenance routines and schedules often lead to poor asset health, and it can lead to unscheduled downtimes and catastrophic asset failure. Another area where this comes into play is the poor maintenance timing. So as I was saying earlier, a lot of times we'll be on maintenance routines and have a schedule for when a specific asset is to have maintenance. Well, without the insights and without the visibility, these maintenance timings could end up being too soon to where you miss a problem that wasn't quite showing itself yet, or they could be too late where you get there and now instead of being just a slight problem where we may need to change a bearing or a consumable, now it's caused wear and tear to other parts of the machinery, and you're now replacing more expensive pieces of equipment because you weren't there on time or you were there too late. And that leads to higher costs, right? Maintaining pieces of industrial equipment is very, very expensive. All of these things, all the parts cost a lot of money. All of the downtime costs you a lot of money. And it results in non-optimized performance, which is going to lead to waste of resources such as your electricity or gas to run the actual pieces of equipment, as well as it's going to waste product because non-optimized and poor performing assets are going to produce less than desirable parts or equipment, and that causes a raise in costs across the board. And what does this do? This leaves us at a competitive disadvantage, right? So our non-optimized production capacity, our degraded health, asset health, and the reliance on poor maintenance practices lead to, again, higher productivity costs, higher prices, and an overall competitive weakness when it comes to being able to produce as much as we should. And that leads us to the OEE barrier, right? A lot of factories that there's the elusive, hey, we're just trying to hit 70%. You know, we would like to utilize our equipment the best that we can. And from my experience in visiting a lot of these places, one of the leading causes to preventing folks from being able to surpass these OEE barriers, excessive machine downtime. When critical assets or critical parts of the line are taken offline due to breakdowns or sluggish performance, it costs a lot of money. I mean, everybody who is running a production facility knows that the longer that line stays down, that's just dollars and cents adding up. And this has significant implications for the entire manufacturing facility, not just cost, but again, with the quality of the parts being produced, safety for the operators, and employee morale. I've been to a few facilities where production numbers directly impact employee benefits, and if their equipment just keeps breaking down over and over again, that's going to cause them to not be happy. And then once you have unhappy employees, it's hard to keep that morale up and keep everybody focused on the mission and trying to get what's needed done. Another area where we've noticed a huge issue with breaking those OEE barriers is production quality. So again, the machines that are running suboptimally or running under spec are going to produce parts that are not good. And then you have the cost of waste on those parts, and you're wasting your time running a line that's producing not good parts, as well as putting wear and tear on those assets and pieces of equipment as they're running, just for nothing, because we're gonna have to throw this whole batch into the trash because it's not doing what we need it to do. And a lot of that is caused by process inefficiencies. So again, with the non-optimized assets and equipment, we notice that asset life cycle tends to be degraded, and it shortens the operational life of a piece of equipment, not to mention the amount of downtime that it takes to get that piece of equipment up and running again. It becomes very expensive and time consuming to keep these pieces of equipment going and these assets going. And then the production output is degraded as well. So this is, again, causing massive financial implications across the entire facility, and it can end up impacting so much that you have to spend a lot of money replacing equipment. And finally, we have process control limitations, another area which affects the OE barriers quite a bit, and that's dependency on human intervention and manual inputs to try and optimize our equipment. Humans and manual processes are prone to fail. Often they're inefficient, and they can't be as precise as what we are able to see from an AI output. Another area where I've noticed a lot of issues with process control limitations is the handover, poor shift handover from shift to shift. I visited a facility one time where they took a lot of manual notes on everything that would happen throughout the shift, and they would often run a run to failure method to where, hey, we're just going to let the machines go, and when they fail, we'll turn some knobs and push some buttons and try and figure out how to get them back going, and we're going to write it down in our log. Well, that ends up with everybody from one shift spending the last hour of their shift, and the next shift spending the first hour of their shift talking to each other, trying to figure out how can we get this machine or this equipment back up and running, and wasting time. This is precious production time where the machines could be running. So these poor process control limitations or poor handovers end up affecting quite a bit across the board. So what can be done about these problems, right? So poor maintenance, lack of observability, the OEE barriers, they can all be assisted with AI, the AI-enabled digital factory. This provides intelligence and the power to transform or transition current manufacturing processes into an industry 4.0 manufacturing process. And so with this, I'm going to kind of explain how AI goes about helping transform into this digital factory. The first way that is done is through the digital twin. So a digital twin is a virtual representation of the equipment, the line, the processes in which the data is coming directly from the equipment. So the AI is ingesting the data and creating this digital twin to show you where there are process limitations. It also allows for testing of new processes to see if they can be validated in this digital twin environment. And it also allows for operations and maintenance to see where failures may happen and get those insights that they wouldn't necessarily see directly from the piece of equipment, the piece of hardware, the line itself. And one of the ways that that's done is through health data. So the machine's health data the AI is going to bring in the data from the machine and give it a health score, or give it a normal operating procedures or normal operating parameters in which we know that this machine is running optimally, and then anything outside of that is going to affect that machine's health. So think current on a actuator for a robotic welder. So you got your 6-axis robot, and it's got actuators that move everything where you need it to go. Well, if one of those actuators starts drawing higher and higher current from the electric motor, or for the electric motor, that is going to affect the health of that machine. Obviously, there's something going on in that piece of equipment that is preventing that actuator or electric motor from performing at the ability that it was able to perform before. And so that health data is collected, and it allows for early detection, right? So we start to notice that those currents are coming in and everything's not working the way that it's supposed to. And so this allows us to detect those performance anomalies that are happening in whether it be a robotic welder or conveyor belt. This is going to be more reliable than human detection, right? Because an operator working at this station that has a robot, or working near the conveyor belt, is not going to notice that the actuator is pulling more of a current than it normally does. They probably won't hear that it has a bit of a different whine to it, or that maybe it has had a catastrophic thing happened where it's got hit and knocked out of alignment enough to where it's chewing gears. None of that is going to be, or some of that is going to be very hard for humans to detect. And that's where the AI is going to come in and really allow for those insights to be gathered and to be viewed by the folks that are making the decisions. And this is also known as root cause analysis. So let's say we do have a catastrophic failure on our line, or something bad has happened and now our asset is down, it's no longer working. The root cause analysis is going to provide analysis of what was going on in that machine at that time that caused this to happen. It's going to say, hey, you know, the current on that electric motor was much higher than normal, and that is generally a sign of a bad bearing on this piece of equipment, meaning it wasn't working correctly, or it hadn't been greased properly. Whatever it was, the bearing was bad, and now the motor has faltered, or that piece of equipment has faltered in a way that has shut down production. And all of this comes from the AI. And one of the cool things about the AI is it's self-learning, right? AI algorithms are able to learn from the processes and the changes that are made. So the AI ingests the data. It's going to learn the normal operating parameters of what's going on in that machine. And then it's going to provide insights to the folks who are making the decisions on how the machines are operating. And it's going to provide them with more data than they had before to make good decisions on the operations of these machines, these assets, these lines. Well, this is a big feedback loop, right? It's a closed loop to where I get better data to make better decisions as the operating manager, as the person in charge of production at my particular facility. So I'm getting this better data and I'm making better decisions, which is feeding better data back into that AI. And that's going to cause this loop to where you start seeing OEE numbers start shooting through the roof, because you're making these micro insights into macro choices for the entire line. And over time, this feedback loop just continues to get better and better. And as the AI learns, it continues to get better and better. Another aspect of that is self-managing, right? So think automated workflows for better execution of complex processes within the line, or letting the folks in the need to know. So letting your maintenance team know that there's a trend towards failure by an automated workflow that's going to send them a ticket and to their email box and say, hey, you might want to go get out to asset 7. We've noticed a significantly higher current being pulled for the electric motor, and now you're able to get out there, spend 5 minutes changing a bearing as opposed to spending 5 hours with a line completely shut down trying to figure out what exactly went wrong inside this machine. And all of that leads to intelligence, overall intelligence of the entire manufacturing process. Think fully automated, intelligent factory, right? Using the self-managing and self-learning AIs to get the most out of the asset, the most out of the lines, and enabling the folks who are making the decisions to meet and exceed all of their goals and expectations when it comes to the performance of the line and the assets involved in that process. All right, go on to the impacts of AI. So what are the impacts? I know I just talked a lot about everything that the AI can help the manufacturing process do. The impacts of that are going to be great. So such as causality identification. The AI is going to study the asset's behavior and give all those insights of all the causes of the failures and everything that might not be going right, and get down to a minute level where it's really allowing for precise tuning and the ability to hone in the performance of this equipment. Studying these insights grants the improvement cycle of performance to just get better and better and better. Another area where this is going to be a huge impact is your optimized load balancing. Think of being able to determine the exact right size of buffer that is needed to be placed between two assets that cycle times might not match up exactly with what they're supposed to. The AI is going to be able to give you the analytics to say, you know, I need to place a 6 widget buffer between these two pieces of production equipment so that by the end of the shift, I'm finishing with a completed cycle of everything. And I'm also not sitting here with a bunch of half-finished products between these two assets. So really optimizing that load between those. And this is going to lead to better overall machine and operator utilization. So managing to optimize the load balancing is going to be able to tell you which asset needs an operator at it a bit more, which one may not be needing it quite as much. Another impact of the AI is going to be the worker empowerment, right? Knowledge is power. This is going to allow those who have stake in the performance of the line, the insights and the AI-enabled analytics to make those right decisions and really start that feedback loop of getting the best out of every piece of equipment that you have on the line. It allows for more intelligence decisions and a deeper understanding of the factory performance through and through. And with that, you're able to reach those better goals of having the continuous improvement, right? So over time, you start seeing your OEE scores continue to improve. The AI algorithm continues to get better at what it's doing and helps lead to better insights and better data, making higher quality products and production decisions, and having more predictable insights of equipment behavior and knowing what they're going to do and when they're going to do it. And all of that is going to lead to reducing the cost of goods sold, right? So the better our equipment is producing goods, the less waste I have, the less I'm spending on it. And at the end of the day, that is the goal of all manufacturing facilities, right? We want to keep the equipment up as much as possible and produce as many goods as possible and get them out the door. Well, this is where AI comes in very, very handy in the ability to be able to give you those insights as the owner of production or the folks in charge there. And it just is good at reducing those costs of goods sold. So with that being said, let's jump into how we at MicroAI view Industry 4.0 and our architecture and how we take care of a lot of these problems. So as you'll see here, the first level, obviously machines, whether it be robots, CNCs, bottlers, it doesn't matter. There's a machine. A machine's got to do a function. Often those machines are controlled by, oh, wrong direction, my bad. Those machines are going to be controlled by sensors, control systems, PLCs, and this is where we're going to have our first layer of AI. This is going to be the intelligent endpoint. So this is going to be an AI designed to monitor a specific asset and report its health and give all the insights into one specific asset. The next layer up, you're going to start seeing gateways and controllers that are monitoring multiple assets at the same time. And we're starting to get these flows into the line and the way that the line is operating. And that's where we've put the next layer of MicroAI, and that's going to be at the intelligent edge. This is an AI that's going to be designed to monitor groups of assets, several channels from each asset, and be able to determine how the flow from asset to asset is going and where we're seeing issues. And then above that, you're going to start getting into where we are now, where you have low latency networks streamed all across a production environment. Imagine a large production facility where one piece of equipment is way far away from the end piece of equipment. Well, in a lot of the modern facilities that we've been to, they're using low latency 5G, 4G networking to get all of the data from all of this piece of equipment. And that's where our next layer of MicroAI is going to go, the MicroAI factory, the digital factory. This is going to bring in the entire line and the workflow automation and the MES data and monitor for OEE across the entire facility. And the cool part about this is that it provides the ability to network several facilities together, right? So this is something that if you're in charge of multiple manufacturing facilities, you have the ability to go in and look at what's happening on each production line at each one of these facilities and determine, are my folks doing what they need to be doing? Are they able to make the right decisions? Think of it as digital layers over physical objects that are providing that deep, deep level of insight across every aspect or every layer of the spectrum. And so let's get into how exactly we at MicroAI do that, right? So we call it deploying the digital factory. So we're going to bring in sensor data, control system data, service data, whether it be through your MES or CMMI, PLC networks, and we're going to ingest that into our AI, depending on which level. It's going to be pre-processed and trained right there at the right there on the equipment that it is coming from. And then we're going to make our inferences through the AI engine and then send out our outputs. And with those outputs, we're able to have that predictive maintenance, right? So we're going to give that machine health score that's going to tell you, you know, this machine's doing really well or this machine's not doing so great. We've noticed a few of these areas that we're monitoring within this machine have been out of where they should normally be. And that machine health score is going to be used to provide a days to the next maintenance. So to combat that poor maintenance routine, we're going to give a days to next maintenance to where each health score impacting event is going to adjust that days to next maintenance. So that way our maintenance team is able to get out there and perform the things that need to get done when they need to get done, rather than waiting too long or going too early. And that gives us expected device failure, right? So now we know, hey, you know, this device over here is not doing great. Another area in which we provide those outputs is through our workflow management. Think automated work tickets, like I spoke on earlier. So I have a ticket that's generated from a specific piece of equipment and sent over to my head of maintenance, and he checks it, makes sure that it is a valid ticket and that everything is good, and then he sends his maintenance guy out there to get it taken care of and signed off. That really helps to minimize the amount of time that our folks are spent trying to figure out what the problem is, and allows them to fix the problem. And this also, the automated workflows, a big one here, and I've harped on it earlier in the webinar, but that end of shift handover. A lot of places that I've been to and I've seen, this can be a real nightmare for a lot of folks, especially if it's something that is taken through manual notes, or the person who doesn't take it isn't, or the person who normally takes the notes on that shift handover isn't there that day. And so second shift doesn't know exactly what's going on. They don't know that this piece of equipment has had a lot of trouble the last shift. All of this can be taken care of through intelligent workflow management. And then finally, we are going to visualize and be able to see those OEE impacting events. We're going to get that root cause analysis that says, hey, this machine, it started going bad because of this, this, and this, whether it be the current that it was pulling was high, or we notice it was having strange vibrations, which tends to be a sign of sounds within the piece of equipment. It could be that the cycle times are messed up. Hey, you know, something's going on here. This piece of equipment normally is supposed to finish its job in 51 seconds, and 10 cycles today, it was in the 70s. We're going to be able to get those OEE impacting events, and with that, be able to view the efficiency of the asset and the operator, depending on the layout of the line and the way that everything shakes through. And so how do we do this? With the digital factory in a box. So this is a turnkey plug and play AI ML solution that it takes real minimal effort to get those AI insights and to start having the ability to see what is going on in the inside of those machines. And like I said earlier, the servers can be networked across multiple factories, so you have the ability to view multiple production environments all from one single pane of glass view. It's this thing we refer to as the smart factory in the box, right? And so what comes with that is a server, the hardware, the networking equipment, racks and closures, install and setup, that all is included in the smart factory in a box. On top of that, you have the AI solution and all feature enhancements and production upgrades included for the future. And then above that, you have the managed services such as training, support, on-site training, user support, and managed services for the software and hardware. And all of these are done, the factory solution is done through our integrated server appliance partners, and we ship globally and take care of all of that. So that's coming to the end here. Go ahead and send it back over to Shrew for the question and answer portion of this. And I hope that this was insightful and kind of got you guys thinking about, you know, how can we use this AI enabled technology to really enhance our ability to produce.
Yeah, awesome. Thank you so much for that, Abe. That was definitely packed with a lot of insights on the digital factory. Before we do get to the Q&A, I want to let you guys know that if you go to your handouts section, there is a couple of collaterals, 2 white papers, right? One on the digital factory, and everything you need to know about optimizing your digital factory, and also another one about the digital twin. So those are free downloads. Make sure you do grab them. And I'll just go ahead and go straight into it because we do have quite a bit of questions. Gonna quick fire one at you right now. So there was one about waste reduction. So I want to frame this question in the context of this webinar correctly. So one of the
Okay.
biggest factors to boosting profit margins for manufacturers is waste production. So how does enabling factory observability help that?
Okay, so imagine if you're running your factory blind and you have no ability to see how exactly your equipment is operating. That equipment over time is going to degrade in its ability to perform the job that it is designed to perform. And you're going to start noticing more and more products coming off of the line with less and less quality to them. So by observing what's going on inside of that machine, we can reduce the amount of bad products coming off the line because we can see when issues are happening or when we're trending towards failure, and we can avoid having that equipment drift into a way to where it is causing bad unsustainable practices when it comes to wasting of products or wasting of electricity or wasting of valuable resources in the manufacturing process.
Gotcha. Awesome. So actually, to extend on that, since this is a webinar about utilizing artificial intelligence, how would you say that AI help enable that process?
So the way that the AI will help and enable that is it's going to be able to train on the asset or that piece of equipment itself. It's going to learn the mannerisms and the way that each individual piece of equipment operates at its nominal operation. And so once the AI starts to see deviations from that, it's going to be able to report that a lot faster than any human is going to be able to see what's going on in those pieces of equipment. And giving those insights to folks faster and to the folks who are in charge of taking care of these equipment allows them to make better, more informed decisions when it comes to fixing it or replacing it, depending on what kind of insights you're getting. But it's going to allow them to have more time or more of an ability to make better choices.
Gotcha. Okay. So, for anyone who's interested in optimizing and digitizing their factories, how fast would you say that this process can get implemented?
So it depends on the use case, but oftentimes these AI insights can be realized within a couple weeks. Obviously, there's a bit of setup and a bit of learning about what goes on in each manufacturing environment. None of them are the same, but generally what we've seen is it doesn't take long to gain the knowledge to train the AIs on the nominal performance of the equipment. And then once the AI is trained, it's ready to start delivering analytics and insights.
Okay, awesome. Quite efficient. I do have one more question here that I'd like to take from the audience. This question asks, how does MicroAI solutions integrate both the human operators and machines on the same line or factory?
Okay, so that's a very good question. It depends on the line itself. So let's say we have a line where I'm working in between two pieces of equipment. Now, figured into the cycle times of these lines and the way that this line is supposed to work, if I'm supposed to grab a piece of product A or widget A and move it from one piece of equipment to another, there's an allotted amount of time to do that, because each one of these pieces of equipment is working in conjunction with several other pieces of equipment, and I'm working in conjunction with them. So as I pull this piece of equipment out and set it over here, I'm allotted a cycle time. And so being able to see equipment A's piece of a cycle, or equipment asset A cycle time and asset B cycle time, and the piece that's in the middle, if asset B is not starting when it should be starting, now I know, hey, the process is having an issue here, right?
Right.
So asset A finished its cycle great. Asset B started late on its cycle time. Where could the issue be? And that's where we're going to start being able to get those efficiency insights on how the operators are working. Now, is that the solution for every single factory? It depends, but on several use cases, I've seen that be a valid solution for getting those insights into operator performance, because obviously it's very difficult to pull their PLC tag data.
Gotcha. So insights definitely is the name of the game there. And also, equally, if not more important, use case matters. Is that what I'm hearing?
Oh yeah, for sure. I mean, the use case is okay. AI enabled learning on factory and asset equipment is valuable to everybody.
Right.
But the use case when it comes to maybe how an operator fits into that, yes, it would definitely.
Okay. Awesome. All right. So I think that is about all the time we have for questions. I know that there's a couple of questions I didn't get or we didn't get a chance to address. But we do have 2 minutes left. So if you happen to not get your questions heard or answered, please don't hesitate to reach out to any one contact that you actually see on screen. It can be Abe or I, or Brandon or Yvonne. They're a part of our sales team, and they'll be very flexible, very quick to answering any of your needs. And also, I know that this webinar was pretty high level, informational, but we do have a lot of bright and talented machine learning engineers that be more than well equipped to answer the more technical questions as well, pertaining to AI modeling or the implementation of AI and the really nitty gritty details of that. So that's pretty much all we have time for. And just a last reminder that there are some really awesome, insightful collaterals in the handouts section. So please make sure you download that and reach out to us if you do have any questions. Abe, do you have anything else for us?
Thank you guys for attending. It's been wonderful filling you guys in on how the AI enabled digital factory is really going to help set things apart. So I appreciate everybody coming.
Yep, awesome. All right, I'll go ahead and close it out for now. See you on the
Thanks.
next one.